Hi, my name is Naman, and with my teammates Mohsin and Richard, we developed this game. The first step in planning this project was choosing a theme that we were all passionate about, something that would make the game engaging and immersive. We drew heavy inspiration from animes and dark fantasy world, particularly shows like Castlevania and Berserk. The influence is reflected in every part of the game. Like in the intro, you'll see a battle between a vampire and two skeletons, showcasing the supernatural element of the game. The main menu gives you a sneak peek of the boss who is ready to ruin your day. The whole game is packed with action, mystery, and just enough frustration to keep things interesting.
In this video, we'll talk about the key features that our game has to offer. Then we'll also talk about the technical details about the implementation of those features. We'll start off with the player movement.
The player moves in 4 directions, up, down, left and right, using different keys. By default, the player moves at normal speed, but when the shift key is pressed, the character accelerates, making movement faster. The mechanic adds a strategic element as player can rush past enemies or traps when needed.
Standing too close to a trap, enemy, and a boss will cause your player to lose health. And as we can see, every time our player receives a damage, the avatar will vibrate and our player will briefly flicker red. The objective of every level is for the player to collect a key. Once the player have obtained a key, the player then can move towards an exit and go to the next level. In this game, we also have implemented HUD, which allows the players to see how much life they have, the extra life, if they have obtained a key, and also the player can press M to show the minimap, which allows the players to see where they are currently at, stationary and moving, and also they can see the exit, which is represented by a mini door in the minimap. In this game, we also implemented additional features such as swords, which allows the player to attack mobs, shields, which allows us to block damages, and also potions that gives us debuffs and buffs depending on which potions that we take. So that was the first part of our video. Next up, we will cover about the technical aspects of our game.
The first step when rendering the map screen was taking all the properties from the .properties file and putting them into a 2D integer array. I broke this down into 3 methods: load properties, create map, and add elements. Load properties finds the max height and the max width that we would then use to generate the 2D array. Here we read line by line until we find the largest number separating at the comma. After finding the max width and the max height, we then focus on moving all the properties within the .properties file into the map. The first step is to fill the map with -1 to signify that it's a walkable floor tile. We then add mobs and the key. Tiles such as traps and entrances and exits are then rendered in the map actor. Once this is completed, we then move on to the add elements method. Here we add custom elements such as potions, the boss spawning point, coins, and golden hearts. For most of these entities, their spawn point is mathematically calculated. However, for the boss, we wanted to change the spawn point for every single game. This is done by generating a random number, and if this number is equal to 3, then that tile will be the boss's spawn point. However, it is not, then the boss will spawn on the other side of the map, furthest away from the player. For our mobs and our boss, we use 2 separate algorithms to target the player. For the mobs, we use a simple algorithm where we calculate the distance between the player and the mob on both the X and the Y axis. If this distance falls within the given range, 8 tiles, then the mob attacks the player. The algorithm we used for the boss was the Dijkstra algorithm. Here we create a graph consisting of nodes. These nodes are walkable tiles within the map. The boss is able to find the player based on the shortest distance between the boss and the player. This is calculated by the minimum number of nodes between these 2 tiles. Each tile represents 1 distance unit. As the boss is only allowed to move up, down, left, and right, and cannot move diagonally, it must then decide which route is the shortest route towards the player. To create this algorithm, we need to first generate a graph and a node. To fill the graph with nodes, we set every tile as a node, then adding the distance afterwards. If the tile in front, behind, to the left, or to the right is a walkable node, then we add this as a destination, with the distance being 1. To pinpoint the player's position, we keep track of traveled nodes and nodes that we haven't traveled yet. If the current node is the same as the player node, then we break out of the loop and set this as the target node. The mob then uses this information to move node to node towards the player. In our game, the camera position simply follows the player. Here we get the current position of the player in terms of the x and the y coordinate and set it as the camera position. From our gathered experiences, the main thing we all learned was organization and file management. By being realistic with deadlines and our individual capabilities, it would have benefited us to focus on core components and make sure that they are bulletproof. Getting lost in files and poor management at the start of our project prevented us from implementing all of the other features we would have liked to implement. If given the chance to do it again, based on what we've learned and our gathered experiences, we'd be able to implement a lot more features and make the game a lot more playable.